empty promises will wear. I know, and now when all is gone, there is nothing to say. And if you're done with embarrassing me, on your own you could go ahead, tell them what I know now. Shout it from the road. There is nothing to say. And if you're done with embarrassing me, on your own you could go ahead, tell them what I know now. Shout it from the road. There is nothing to say. And if you're done with embarrassing me, on your own you could go ahead, tell them what I know now. Shout it from the road. There is nothing to say. And if you're done with embarrassing me, on your own you could go ahead, tell them what I know now. Shout it from the road. There is nothing to
Okay, Assalamualaikum warahmatullahi wabarakatuh.
I know now. Nothing to
Okay, Assalamualaikum warahmatullahi wabarakatuh. So today what we are going to discuss is we are going to look at back to summary for chemical properties of hydroxy compound. Okay. Okay, for chemical properties of hydroxy compound, if you look at here, there are three ways how we are going to produce hydroxy compound. It is either from alkene or from haloalkane. Okay, then this one is also from Grignard reagent. Okay, so we can start from the Grignard reagent. Okay, for Grignard reagent, so we have R2CH2Br here. Okay, we have R2CH2Br here when treated with magnesium in ether. So we will produce R2CH2MgBr. Okay, and then when the Grignard reagent treat with the ether, we treat with the aldehyde in the presence of ether. Okay, we will produce CH3CH. Okay, so at the oxygen here we have MgBr. Then we are connect with the CH2R2. Then they are undergo hydrolysis. Then we produce CH3. We are produce CH3 CH. So here is become as a OH. Then here is still we got the CH2 R2. Okay, if we are look at to the OH here, okay, carbon with the OH here, the carbon is secondary alcohol. Okay, then if a Grignard reagent then treat with the methanol. Okay, treat with the methanol, we have hydrogen C. Here we got another H. At the O here it become as a MgBr. Then another half of the Grignard reagent, we have a CH2 here, R2. Then undergo hydrolysis, we have H, C, H, then OMgBr is become as a OH. Then here we have CH2, R2. Okay. Then next, this is ketone. This is ketone. So, when the Grignard reagent react with ketone, so we will produce R, C, double bond O, R1. Okay. So, the double bond O here is become as a O, MgBr. Then here it become CH2, R2. After the hydrolysis, we are double check here. So, OMgBr become as a OH. Okay. So, we have at the CH2, we have R2. Then we have R and the R1 here. Okay. So, for reaction for formation of alcohol, as we said that just now, the alcohol is formed from alkene or haloalkane. So, if from haloalkane, so we will have R, C, R1, here is CH2, R2, then this part is any halogen lah, you can use Br. Okay, they are undergo nucleophilic substitution reaction. Okay, if use diluted sulfuric acid, it is from alkene. So, we will have a structure. Okay, R, C. Here is C, we got R1. Then we have a double bond here, CH. Then it is R2. Okay, this is follow Markovnikov rule, where hydrogen from the acid here will go to carbon-carbon double bond that has a greater number of hydrogen. Okay, so there are three ways how we are going to produce alcohol. Okay, if you look at this alcohol, we have one alkyl group, two alkyl group, and the three alkyl group. So this is tertiary alcohol. Okay, so if you look at all the reagent here, okay, here, if you look at all the reagent here, this is the alcohol will undergo nucleophilic substitution reaction except for except the tertiary alcohol cannot be oxidized. Okay, the tertiary alcohol cannot be oxidized. So this one is no reaction. So at this part, okay, at this part, it is undergo nucleophilic substitution reaction. So they will substitute the OH with other nucleophile. Okay. Okay, but let's look at alcohol with the concentrated sulfuric acid. When alcohol react with the concentrated sulfuric acid, they are undergo elimination reaction. They are undergo elimination reaction where they are eliminate OH and the hydrogen from the adjacent carbon. So, we will produce R, C, R1, double bond, CH, R2. Okay, if with sodium, okay, so reacted with the metal. When we react with metal, dia akan jadi R, C, R1, CH2, R2, but at the oxygen here, okay, in this case, alcohol as a nucleophile, then O minus and A plus. Okay, next, this is esterification. When alcohol react with the carboxylic acid, okay, in acidic medium, when we heat it up, so this is esterification. So esterification, or for this one, okay, both we will produce the same product. So we will produce R, C, double bond O. Then for first structure, we are eliminate water. For the second one, we will eliminate HCl. Then we will produce C double bond O, O. So we are remove this hydrogen. So O, we got after O, we got C. Then we have R1. Here is R. Then here is a CH2. R2. Okay. What about, okay, this start from this part. Okay, from zinc. Okay, we start from zinc. Concentrated HCl, zinc chloride. Okay, we start from this part. They are undergo nucleophilic substitution reaction. Okay, when react with HCl in zinc chloride, so we produce R, C, R1. Okay, then we have CH2, R2. Okay, add the carbon with the OH here, we are substituted with the Cl. Okay, for HBr and PBr3, will produce R, C, R1, CH2, R2, then here is Br. Okay, what next? Okay, for PCl3, PCl5, and SOCl2, all this we produce R, C, R1, Br, CH2, R2. Sorry, it is not Br. Okay, it is supposed to be Cl here. Okay, but a tertiary alcohol cannot be oxidized. They cannot reduce manganese MnO4 to Mn2+. Okay, this is secondary alcohol. So the secondary alcohol, we change the purple color of potassium permanganate to colorless. Okay, then we are produce. Okay, both this one will be produce CH3, C, double bond O. Then we have CH2, R2. Okay, for iodoform test is used to identify the presence of methyl carbonyl group. What is a methyl carbonyl group? The methyl carbonyl group is carbon with the OH group. Okay, we have the CH3 group there. Okay, so this is methyl carbonyl group. Okay, so if we do have that one, we will produce R2, CH2, C, double bond O, O minus, but because of we are produce yellow precipitate, we will produce CHI3. Okay, then this one is a primary alcohol. So the primary alcohol will directly oxidize to carboxylic acid. Okay, we will oxidize to R2, R2 CH2 C double bond O OH. Okay, as well as it is either we use potassium dichromate or chromate. Okay, both we produce carboxylic acid. Okay, but if we use weak oxidizing agent such as pyridinium chlorochromate in dichloromethane, so the oxidation of primary alcohol will stop until aldehyde. What we have is R2 CH2 C double bond O H. Okay, what next? Okay, next is we are going to look at how phenol, the chemical properties of a phenol. So how phenol react? So this is a phenol, benzene ring with the OH group here called as a phenol. So phenol is more acidic than aliphatic alcohol. Okay, so in this case, phenol will react with the sodium. Phenol will react with the sodium, so it will produce Na plus or minus ion, but it will release hydrogen gas. Okay, if phenol react with sodium hydroxide, only phenol react with the sodium hydroxide, but it will produce O minus and A plus, but the side product is water. Okay, bromine Br2 aqueous or Br2H2O mean that it is a complementary test for phenol, so it will produce, there is a OH, then the bromine will be substitute hydrogen in the position of autopara. Okay, so then last one is a ferric chloride. For ferric chloride, we will produce a purple complex. Then we have Fe okay, FeCl3, sorry. This is a purple complex. Okay, now we've done the summary for chemical properties of hydroxy compound. Okay, we done the summary for chemical properties of hydroxy compound. Okay, now what we are going to do next is we are going to look at the 15 objective question. Okay, let's look at the 15 objective question that I gave you before. Okay, so for question number 1, which of the following is a secondary alcohol? So in order to determine the alcohol, it is either primary, secondary or tertiary, we are look at to the carbon alpha. What is a carbon alpha? As we know that before, the carbon alpha is a carbon that directly attached to the OH group. So we know that if one alkyl group, it is a primary alcohol. If two alkyl group is a secondary alcohol. If three alkyl group is a tertiary alcohol. So our focus today is we are going to look at to the secondary alcohol. So secondary alcohol. So secondary alcohol, we have two alkyl group attached to it. Okay, if we are look at to the option for the answer. Okay, number 3 here, we have carbon. Okay, at the carbon, the last carbon here with the OH group, we have carbon, but at this carbon, we have hydrogen. We have another hydrogen, then we are only have one alkyl group. So this is primary alcohol. Okay, look at second compound. Okay, at this carbon we have 2 alkyl groups. So because of they have 2 alkyl group, it is a secondary alcohol. So number 2 is correct. Okay, what about this one? Cyclohexanone. So for cyclohexanone, we are looking at to this carbon. So we have one alkyl group here and another alkyl group here. So it is a secondary carbon. Okay, so the answer is 1 and 2. Okay. For IUPAC name of the following compound, okay, make sure when you have a CH3 2, so you open the bracket and you rewrite the structure. Okay, I open the bracket and rewrite the structure. Okay, so if we are going to find out the longest continuous chain, we are looking to the longest continuous chain with the functional group. Okay, longest continuous chain with the functional group. If longest continuous chain with the functional group here, okay, then after we have find out the longest continuous chain with the functional group, we are going to give carbon number 1 to the carbon that give the lowest number to the functional group. But in this case, it is either you give number 1 from the left side or number 1 from the right side. It is the same. Okay. Then if you look at here, at the carbon number 2, we have a substituent. So it is the same. We put number 1 on the right side. It is also, we have substituent at the carbon number 2. But number of substituent at the carbon number 2 here, we have 2 carbon group. Okay, because of we are having 2 carbon group, from the left side, we are giving this is carbon number 1, carbon number 2, number 3, number 4, and number 5. So we name it as a, okay, the benzene ring here as a phenyl. So this is methyl. So M is come first rather than P. So 2,2-dimethyl, 4-phenyl, 3-pentanol. Okay, next. What is the IUPAC name for the following compound? We are always give carbon with the OH group as a carbon number 1. So this is carbon 1, this is carbon 2, carbon 3, and the carbon 4. Okay, now we are going to write name of a compound. We are arrange them in alphabetical order. So this is bromo. Here is methyl. Okay, so we are arrange them. We said that for bromo, 3-methyl cyclohexanone. So the answer is supposed to be 4-bromo, 3-methyl cyclohexanone, not 5-methyl cyclohexanone. Okay. Why the answer for number 1 is wrong? Okay, the 1-bromo, 2-methyl cyclohexanol. We cannot put number 1 at the bromine here because the priority is functional group. Okay, 2-bromo, 1-methyl cyclohexanol. So we are also cannot give the CH3 group as a carbon number 1 because of priority is a OH group. 4-bromo, 5-methyl. Okay, in this case, the last one here, okay, I redraw the structure. Here we have OH, here we have Br, here we have CH3. Okay. So, they put, this is a carbon 1, here is carbon 2, 3, carbon 4, and the carbon 5. What's wrong with the name? Okay, the priority is the carbon chain that have the OH group, but they are not giving the lowest possible number to the substituent. Okay, number 4. Okay, which of the following compound has the highest boiling point? Okay, the one that has the highest boiling point. Okay, let's analyze each of the compound given. Okay, if you look at here, we have 1 carbon, 2 carbon, 3 carbon, 4 carbon. Here is, we have 1 carbon, 2 carbon, 3 carbon. Here we have 1, 2, 3, 4. Here we have 1, 2, 3 carbon. But A and B has only 1 OH group, while C and D has 2 OH group. Of course, the one that more number of OH group will have a higher boiling point. Okay, so A and B has a lower boiling point. Which C or D has a higher boiling point? In this case, both has the same ability to form the hydrogen bond. But in this case, the shape of the propane diol is more spherical than 1,3 propane diol. Okay, so due to the surface contact area of 1,3 propane diol is larger than C, so 1,3 propane diol has a higher boiling point than 2,2 propane diol. Okay, number 5. Okay, number 5. Okay, let's analyze one by one. It says that here, which of the following list is correct order of increasing acidity? Okay, increasing acidity here is discussed on ability to donate proton. Okay. Okay. If you look at the list of compound given, okay, they are having the same compound. Okay, we are analyze one by one. Okay, if you look at here, HCl is a stronger acid than ethanoic acid. Okay, ethyne and ethanol. But in this case, of course, HCl is a strong acid. Okay, this is weak acid. Here is a very weak acid, but this one is not acidic. Okay, so which one highest acidity? So HCl has the highest acidity. Between alcohol and the carboxyl group, okay, alcohol and carboxyl group is more acidic because of the resonance structure of carboxylic ion. It make the hydrogen of the carboxylic ion become easier to donate its proton compared to ethanol, where the electron at the OH group is localized at the OH group. So the bond between O and H become stronger than the ability to donate the proton is hard. Okay, so number 1 HCl. It is 2 this one, 3 alcohol, and the last one is ethyne. Okay, then the answer is C. Okay, number 6. Okay, number 6. Which of the following is the strongest acid? Strongest acid. Here we do have all is a 2 carbon. But the difference between them is this one we have fluorine at the carbon number 1. Here we have chlorine at the carbon number 1. Here we have fluorine at the carbon number 2. Okay, so C and D, they have the same positions of the electron withdrawing group. Okay, effect of the electron withdrawing group is they will withdraw the electron from the OH group, it made the density of the electron at the OH group become less, then the bond between O and H become weaker and easier to donate the proton. So the more closer the electron withdrawing group towards to the OH group, the ability to withdraw the electron to decrease the electron density at the OH group become higher. It make the bond between O and H become weaker and easier to donate the proton. So between C and D, D here, the fluorine is at the second carbon. So if D at the second carbon, it is far from the OH group, so hard to donate the proton. Okay, but now for C and B, okay, both have the same position of the electron withdrawing group. Okay, but why C is my chosen answer? Because of fluorine is more electronegative than chlorine. Okay, why fluorine? When fluorine is more electronegative than chlorine, it make one fluoroethanol more acidic than one chloroethanol, because fluorine has a higher electronegativity. They have a higher ability to attract the electron and causing the electron density at the OH group become less, then the bond between O and H become weaker, then easier to donate the proton. Okay. Which of the following react faster with the HCl? Okay. The question now is quite confused. Okay. If we look at to the ethanol is a primary alcohol. Okay, ethanol is a primary alcohol. When we are going to answer the question, we need to analyze the answer one by one. Okay, we need to draw, we need to sketch what we have. Okay, one propanol. So one propanol, it is a CH3, CH2, CH2. Then we have the OH. Then one propanol is also primary alcohol. And then two propanol, CH3, CH2, CH3. So two propanol mean that the OH is at the second carbon. So this is a secondary alcohol. What about 2-methyl-2-propanol? 2-methyl-2-propanol, we have 1 carbon, 2 carbon, 3 carbon. So at the carbon number 2, we have a methyl group. At the carbon number 2, we have the OH group. Then we octet the other carbon. Then this is a tertiary alcohol. So if the question asks you, which of the following react faster with HCl? Of course, the one that react faster with HCl is a tertiary alcohol. Then the answer is 2-methyl-2-propanol. Okay. Okay, next. What is the major organic product from the reaction of 3-methyl-2-butanol with HBr? Okay, now first thing first, you need to draw 3-methyl-2-butanol. Okay, how was it look like? 3-methyl-2-butanol. 2-butanol, we have 4 carbon. 1, 2, 3, 4. At the carbon number 2, we have the OH group. While at the carbon number 3, we have a methyl group. And the rest of the carbon, make sure you are octet all the carbon. Okay, we have one hydrogen and another hydrogen. Okay, dia kata it react with the HBr. So when it react with the HBr, in this case, they are undergo nucleophilic substitution reaction where they will substitute the OH here with the Br, then they are eliminate water. So it become as a, this one change to the Br. So it become as a, this is carbon 1, this is carbon 2, carbon 3, carbon 4. Okay. it might be some of you confused. It is either you are going to put carbon 1 from the left side or from the right side. In this case, it is balanced. It is either the position of the substituent from the left side or from the right side is at the carbon number 2. Okay, if they have the same balanced substituent here, you are look at to the alphabet. Okay, so methyl. Okay, we do have a methyl here with the word M, and a bromine here with the word B. So B is count first. So we put carbon 1 from the right side. So we name this one as a 2-methyl 2-bromo 3-methyl butane. Okay. Okay. Here. What is the best choice of reagent for the following conversion? So, if you do not understand what is CHO, remember the Hong 1, 2, 3, 4 rule, HONC 1, 2, 3, 4, where hydrogen has 1 bonding, oxygen has 2 bonding, nitrogen has 3 bonding, and carbon has 4 bonding. So in this case, the structure is CH3, C double bond O, H. Okay. So from alcohol to this is aldehyde. Okay, this is aldehyde. From alcohol to aldehyde. Is it suitable to use sodium hydroxide? This where they are undergo oxidation. Sodium hydroxide is not the oxidizing agent. OS4 is also not the oxidizing agent. Then we have 2 choice here. But potassium permanganate is a strong oxidizing agent, while pyridinium chlorochromate is a weak oxidizing agent. So in this case, we are going to stop anti-aldehyde. So we use the pyridinium chlorochromate as a weak oxidizing agent. Okay, look at this one. What is a major organic product from the following reaction? So this is a primary alcohol. So all the primary alcohol will be oxidized to the carboxylic acid. Okay, what is the best description of ethanol in this following reaction? Best description. Okay, the ethanol here. Okay, if you redraw the ethanol, you have CH3, CH2. At the CH2 here, you have O, you have H with the 2 lone pair. Okay, but ethanol not undergo a nucleophilic substitution with the HCl. Okay, so they are preferred to accept proton. Okay, HCl here. So both of the bonded electron is taken by the chlorine. It makes the chlorine become Cl minus. So what happened to the hydrogen? The H plus here is taken by the alcohol. So H plus, the alcohol here accept proton, donate electrons. So if you look at this is arsenous acid. So what did Arrhenius say about the acid? Arrhenius said acid is a substance that are dissolved in water and produce H plus ion. While Bronsted-Lowry said about acid is a substance that are able to donate proton. So now the ethanol here are not donate the proton. The ethanol now are accepting the proton. So it is not correct with the Bronsted-Lowry. It is not correct with the acid because of they are not produce H plus ion when dissolved in water. Then now they are treated with the HCl. Okay, and then if Lewis acid, according to Lewis, acid is a substance that are able to accept the electron. Okay, so do ethanol accept the electron? The ethanol are already has the electron here, but it is accept the proton. What Lewis base? Lewis base is a substance that are able to donate its electron. So the answer is C. Okay, question number 12. Okay. For question number 12, what is the best choice of the reagent for the following transformation? They are transformed. We have the OH here, we have a Cl. But it says that here the best choice. So, look at to the choice of answer. Okay. Alcohol does not react with the chlorine in the presence of UV. Chlorine in the presence of UV, this is reagent for alkane. Okay, chlorine water pun I don't think they are react. Okay, sebab dia tak react. If HCl and SOCl2, HCl is quite slow when react with the alcohol, then the best choice is SOCl2. The reaction with the HCl is quite slow. They can react, but it is slow. That's why the question there asks the best choice. So you need to choose the best one. Okay. For question number 13, is this the same with the question number 12? Okay. It says that here, what are the reagents suitable for the following transformation? Okay. It is the same question, but the question are not what are the suitable reagent. Of course, here, if you look at mean that more than one. Just now we have choose SOCl2. Okay, what are suitable reagents? Then I choose SOCl2 and HCl. Do we have Cl2 and H2O that react with the alcohol? Okay, if you look at back to the summary that we did before, no reagent Cl2 water. So, dia tak bertindak balas lah. Lagipun Cl2 water ni dia lebih kepada addition reaction. Okay. So, the answer is B. Okay, 14. What are the possible product of the following reaction? The possible product of the following reaction. Okay. This is alcohol. Okay, react with sulfuric acid, concentrated sulfuric acid, but then we heat it up. So, they are undergo elimination reaction. They are undergo elimination reaction. So, if we still remember, during the elimination reaction, the mechanism, we are remove OH. Okay, we are remove the OH, then this carbon become as a carbocation. Okay, this is secondary carbocation. Okay, if we are look at two other carbon that we have inside the structure, this is tertiary carbon. This is secondary carbon. This is secondary carbon. This is a secondary carbon. So, we have a more stable carbocation. How do we know that the carbocation is more stable? The more the alkyl group attached to that particular carbon, the more stable the carbon it is, because of the alkyl group is an electron donating group. They will increase the electron density at that carbon. It make the carbon positively charged become more stable. So, the compound now, okay, so we have CH3, then this is the carbocation. Okay, if this is a carbocation, the probability, here we have a hydrogen, here we have also the hydrogen. So, the probability to form alkene, it is either we make a double bond here, or the double bond here, or the double bond here. Okay, so let's look at the choices of answer. Okay, of course, we have number 1, we do have this one with the CH3, with this one. Okay, for number 2 also have. And for number 3, okay, it is wrong. So, the answer is B. Okay, last question. Okay, 15. Which of the following statement is or are true regarding to the properties of alcohol. Okay, now look at to the question. Dia kata is or are. So, you may choose one or more. Alcohol less acidic than water. Yes, correct. Alcohol is less acidic than water. Okay, alcohol are constitutional isomer than ether. Alcohol have the same molecular formula with the ether, but they are not constitutional isomer because of ether and the alcohol come from a different family. They have a different functional group. Okay, so it's supposed to say that alcohol are functional group isomer. Yes, if they say that functional group isomer, the statement is correct. Okay, tertiary alcohol undergo oxidation to form a ketone. Okay, we know that the tertiary alcohol can undergo oxidation. Then, if the alcohol that produces ketone must come from the secondary alcohol. Thus, the answer for the last question is one only. Then the answer is A. Okay, so we finish revise chapter alcohol before the UPS. Then hopefully you do well during the ujian summative this Monday. So that's all. Then we will continue tonight with the carbonyl compound.